Well, hello and welcome back to our third workshop in a row. Trust everybody's having a great time, hanging out with all of you. Really good to see everybody coming along. And I notice we've got many different places represented. We've got Russia represented, Italy represented in spades, got a good Italian contingent. We've had Canada represented, the USA, of course, and various other South American countries as well. Notice Flavio in from Brazil, so it's good to have everybody along. We've got a workshop now from our very own Luca Pradovera. How are you doing today, Luca?
Great. Ready to have a lot of fun.
Good. We're ready to be on the receiving end of the fun. Now, for those of people that have not come across SignalWire before, SignalWire Cloud that Luca's going to talk about is an amazing way of harnessing the power of FreeSwitch and other top tools as well, all inside a global elastic infrastructure that saves you a great amount of work in terms of deployment. There's a couple of different ways of talking to it in terms of APIs, and I know that Luca plans to talk about both of those as he introduces SignalWire. Let me just remind you, we've got more great work and talks at 2:30. That's going to be after this workshop and after we've had a break. We've got our first speaking session when Tony and Brian and Michael will all be in to have a kind of a keynote discussion and Q&A session about the FreeSwitch project. So we're looking forward to that. And we've also got the reveal of the Coda Games excitement that Abby is going to do for us later today. And of course, in the evening, we do have a social time for those people that would like to come and hang out. But in the meantime, Luca, thank you very much for joining us all the way from Italy. So a little bit later in the day for you. And I'll hand over to you now for the workshop. Thank you.
Thank you, David. Always great to be at ClueCon, even if it's not, in person, but it doesn't matter. We are all telecom engineers, so we don't care. We find a way to talk to each other. At least usually when things work. So what is SignalWire about? SignalWire was built out of the effort of Tony Minasale and the other founders, so Evan McKee and Sean Heine and many other people, to build something around a telephony that was a little bit different. So what I want to do today is start from a bit of introduction, just to get everybody started. In case you don't have an account, I'll introduce to some of the key concepts so we can get started quicker. But after looking at a few things in the cloud, in the pure cloud stuff, what I'd like to look at with you is how our newer call control protocol Relay works. Relay is has been termed a spiritual successor to ESL, which is not going to, of course, it's not a one-to-one comparison, because it's Relay is about controlling calls in the cloud as opposed to controlling calls and on your local machines. But it has some analogies, and most of all, it's similar with the persistent connection, where events come back from the servers and you can send commands in. So there's enough similarities that people have been starting to look at it as the spiritual successor of the event socket library. So first of all, though, let's look at a few simple things about SignalWire. I'm not even sure we're going to go through all of this just because I want to look through Relay, but let's stick to the first few concepts. So few useful links. I'll have a link to this. So I have a link to the other slide in the other slides. I'll get a link to this in the chat as soon as we're done with the workshop. But it's already been published, so it shouldn't be a problem there. And just a few things that we were looking at are what LAML is and in general, how it works. But first of all, getting started. So SignalWire is easy to set up. I won't go through the registration. If someone would like to go and register right now, it only takes a few minutes. So go take a look. Just click on the register link on the homepage and just create an account. The important thing to remember is the space name. A space name is sort of your personal or company SignalWire domain that's used for all things, including SIP and webhooks and all of the other stuff that's related to your account. So when you're setting it up, just remember your space name, and the system will let you go forward anyway, so you have to put one in. A few key concepts about the dashboard. The dashboard. So when you create your account, we call that account a space. A space is what is a a space is just the name for the whole account. Every account is divided in multiple space projects. Projects are a logical way to group your resources. So, for example, you could have one project with some phone numbers and one project with with other phone numbers and applications. Note that they're all built together. So the project concept is more tied to something like having a staging and a production project, so you don't by mistake release numbers on your production project, or maybe having something set up for each state your company operates in. So this is for Georgia, this is for North Carolina, this is for Florida. Every space has multiple phone numbers. Or zero. I mean, you can run with zero for sure. We have customers who don't use phone numbers. The LAML is actually what we're going to look at in a bit. Is our call control mechanism that's similar to another provider that rhymes with Billio, and though ours is better. And it is simply an XML-based dialect that you can use to build simple call flows. Then you have SIP capabilities, which are used to interact with SignalWire using the classic SIP stuff. So maybe register endpoints, having your servers registered to SignalWire, which will actually be covered more in depth on my second workshop tomorrow. On the FreeSwitch workshop, we'll specifically see how to add SignalWire trunks to your FreeSwitch server. But also you can not have a server and just use SignalWire for registrations and for inbound calls using domain apps. Then we have Relay, our super important call control protocol that's based on JSON and WebSockets. That's very, very powerful. And there's also an event tomorrow. So if you'd like to join, there's a link at the end of this presentation. But we'll go back to this later in a bit. We also support many integrations, including Dialogflow, Agora, and Zapier, and many others. So you can do a lot of things with SignalWire, which is just not placing calls. In the context of using your account, one caveat, some of you might have registered while I was talking. If not, I will really suggest you do it so we can try some things later. But the main thing is, if you're in trial, you can only interact with your account through verified numbers. What a verified number is a number you've received the call from the SignalWire dashboard, and you have just entered the numeric code that's read to you. Of course, you can also buy phone numbers, but then you have to be out of trial. To get out of trial, just add $5 to your account with a credit card, and that's going to be enough. It's all prepaid, so there's no hidden fees. It's all pay as you go. Our DIDs are very cheap, and I think that's worth playing. That is worth playing with the dashboard just for a bit. But just remember, you need to have a verified phone number, or some of these things will not work, which might be a problem, and it's a snag some people run into. Okay, so you can buy a phone number. I won't go through the motions again, the interest of getting to Relay and the actual call control, but generally speaking, it's kind of like any other dashboard. We support 3 types of number: local, toll-free, and shortcode. For shortcode, you have to apply. Toll-free numbers and local, you could just buy from our inventory. And you can then have you can pick an area code, region, or a combination. There's also an API that allows you to provision numbers if you need to do that programmatically. So quickly handling voice calls on LAML. Then we'll skip a few slides and go straight to taking a quick look at SIP before we go with SIG into Relay. So LAML is, again, just an XML dialect. Some of you might be familiar for if you used other providers, and it's got the usual features that you expect. So you can do a little bit of templating. It doesn't have logic, but you can pass in variables, and then those variables get interpolated. And the various so there's a REST API to place outbound calls, again, using REST. This is not strictly tied to LAML. It just will place outbound calls, and then you can have the call be handled by many handlers. This will go through in a bit. Roll back. Caller ID. Oh, okay. So this is important. This applies to Relay too. When you will be placing outbound calls using the SignalWire API, any of the SignalWire APIs, remember that there's a few rules to abide to, because we'd like to avoid abuse of caller IDs. So what's important to know is that the only caller IDs you can use on a call are numbers you own on SignalWire, numbers you verified, so what we went through earlier by calling your number, Only when a call is an inbound call via a DID SignalWire DID you own to a LAML, you can use the caller ID from the inbound call. So if I'm calling into SignalWire is allowed to use my caller ID to dial outbound, because it's assumed that you're calling into an application. That application might need to use my caller ID to dial out. Or when you're dialing out using an outbound SIP call, you can use any caller ID, but you have to specify one. So there has to be a caller ID set. Note that you can use any caller ID, including anything that your destination SIP server will accept and will be parsed and whatever. So you're not limited to phone numbers. Of course, you have to specify one, or the system will pick one at random from your existing numbers. That's always true. If you don't specify one will be picked at random from your existing phone numbers. Still, keep in mind you cannot just use anybody's number to dial out for obvious reasons, but there's ways to alleviate that. Just a quick run through LAML, so we can compare this to Relay later. And as you see, LAML provides a way to do dialing to number, conferences, and queues. You can handle a queue by using enqueue and leave. There's a way to get input. There's a way to hang up, of course, pausing the call, playing audio, redirecting, rejecting a call, saying something with TTS, or streaming RTP to a different endpoint. This is really the base setup for LAML. It's what you'd use to build any of the scenarios. For example, just to go into one of the verbs, we can see how gather has many interesting parameters. It has action, which allows you to specify where the result of the input will go when you receive input, and an HTTP method, what type of input you're expecting, speech and DTMF here, and we're going to time out on 5 seconds or when one digit is pressed. So you will say or enter your account number followed by the pound sign. No, there's no terminator here, so that's actually wrong. But the point is, you get a confidence and speech result variable if the user has spoken something, or you would get just the digits back if the user hasn't said anything. Our speech recognition will generally return the numbers in digit form already. So 95% of the time, unless the person is speaking with a weird accent or they have bad audio, it will just be, if you say 1, 2, 3, 4, it will just be the digits 1, 2, 3, 4. So you can process that the same way. You will get a webhook that has a few information points on the call. Your account said, your call said, where the call was coming from, where the call was going, who was called. So the difference between to and called is to is the current destination. Call is what the original caller dialed on their phone. And then the various status options, like if it's queued, which way it was going, etc. Of course, LAML supports messaging, as does Relay. So sending messages and receiving messages is very simple. You set up a webhook and you get a message back, or you set up or you do it with REST and you just send messages. This will look at more in better detail in the Relay version, because it's more interesting. I mean, messaging is messaging. It's pretty simple. However, it's worth knowing that SignalWire has a code of conduct we need to adhere to. Is not even just us. It's generally speaking how the industry is going. Plus, as you know, the industry has been introducing extra charges, etc. So messaging right now needs to be handled with a little bit of attention more. So before we move to some more technical stuff, just remember that avoiding public URL shorteners is a good idea. So generally speaking, bit.ly links and that stuff is really not very well accepted by carriers these days. Always have an opt-in clause.
Can I just jump in a minute just before you carry on? Because Johnny has asked a question in the chat and says, can LAML give webhooks during the state of the call, but not totally controlled in the LAML bin?
No. The call will be, so there's no way to just get the call statuses without getting the call actually the call actually working.
Okay, thanks.
So there's that's something you will probably be able to do with Relay with some creativity. So that's a good idea. We'll try and figure out a way in just a bit. So it's more fun that way. And I'll keep the chat open. Sorry, I just closed. Okay, so again, avoid links. Always have an opt-out clause. These days, having an opt-out clause has become essentially necessary. Otherwise, your campaigns just won't work. here, keep in mind, here I'm talking about semi-mass messaging. Like if you're sending hundreds or thousands of messages, you need an opt-out clause, otherwise it won't work. Personalized messages are also very well received by carriers. So stuff like, hello, Luca, here's your appointment for tomorrow. Reply stop to get the to unsubscribe. Or you see there's an option, there's an example at the bottom. Use toll-free numbers. Toll-free numbers are much better. Of course, short codes, so they're more expensive. Of course, so that bottom example is a good example of how you'd send a message that actually gets through most carriers. Again, this is not a guide to hacking carriers. They're big, they're slow, but they get angry very fast. So gaming the system won't work for long. So what I will suggest really is just having the just abiding to the code of conduct. Of course, reach out to any of our team to ask more about this, and I'd be happy to help. Messaging has become noticeably more complicated in the last few months. So it is understandable if some of the things that used to work don't anymore. Okay, so going back to, I don't know why. Oh yeah, faxing. So faxes still exist. Contrary to the popular opinion, faxing apparently hasn't met its demise yet. So we do support faxing. Just set up a phone number. You can send faxes using the API, and you'll receive faxes on a webhook. It's actually quite effective. I just don't like faxing at all. So, of course, I understand that especially in the American healthcare industry, faxing is still very much alive and kicking. All of these are supported by Relay 2, so that's why I'm just going through this. Also, we already did part of this workshop at ClueCon last year, so that's why I wanted to do something newer. But still, it's worth helping people going through this before the hands-on part. Receiving fax is similar to an SMS. You will get a webhook on the URL you set up that will let you know things like the media URL, the status of the fax, and how many pages were sent. It's effective when you need faxing, which is, I hope not very often, but of course, if you need it, it's there. Sending a fax via REST, again, is just a request away. The SDK supports sending faxes to PDF. So the PDF has to be publicly available on the web to be sent. Of course, you can use an S3 pre-signed URL. So, a good question from Anthony. SignalWire will offer the option to send P2P versus A2P. So we're not currently able to, but I know that's something that's been worked on. So we'll certainly have a very big update the moment we find out more. It is not with us as a problem. It's a matter of carriers being very much opposed to people having that option. So we're still working through the various hoops. Again, unfortunately, messaging has become very, very complicated in the last few months, to the point where faxing is probably easier. So people break out your 90s fax machines. It's thermostatic paper time again, apparently. Okay, so more interesting stuff. SIP. SignalWire supports outbound dialing to SIP URLs, inbound calls via subdomain apps, and registering endpoints. So we have many customers who don't have their own infrastructure anymore and just run calls on our SIP infrastructure. So just a quick run through in turn. So a SIP endpoint will be a server or a device you register. These, of course, can also be created through an API. So you would just create a username and a password, and then just register a device using that username and a password. We generally support the classic codec setup, so they're all in the page. So if you'd like to check, but we support PCMU, PCMA. I know there's people using a variety of devices registered against endpoints, and I know there's a lot of people using them for servers too. It's just a SIP peer, so you can register that from any SIP-capable device. That will probably help some people that are on the fence whether or not they should be running their own subserver or not. Many times it's more cost-effective, more easy to control, having your own stuff. Sometimes it's just easier to use something that's prepackaged. So this being the context of ClueCon, I'm saying our SIP is very good, but also use FreeSwitch, which is very fun too. And we'll do that tomorrow, actually. Inbound SIP, domain applications. So this is where it comes in to be more interesting, probably, as opposed to the endpoints. What is a domain application? A domain application is a SIP URL you create on SignalWire. You can then send calls to. So if I create an app and call it your new DApp, I will get a URL that's yournewdapp.sip.signalwire.com. Anything I dial at that domain will end up being handled by my LAML webhook or by a relay. This is actually, in my opinion, more useful than endpoints, because this way you can easily integrate SignalWire in your existing flow. Say you have multiple FreeSwitch servers and you like to do all the cool things SignalWire supports. So speech recognition, multiple input modes at the same time, streaming audio or video out to RTP endpoints or over WebSockets, all the kind of stuff that it's usually harder to do locally for various reasons. What you could do is set up a domain app as your entry point. You can whitelist IPs, so only your servers can call that domain app. And then you can have your domain app do whatever you want. This is actually a very interesting mechanism and integration entry point for FreeSwitch. So if you already have a fleet of FreeSwitch servers, you already have a SIP infrastructure, but you'd like to add some of the SignalWire magic to your applications, by all means, look for the domain app, because it's the best way to get started. You can then just have FreeSwitch anonymously dial out to a gateway and just bridge the domain app. It can even hairpin, so you could call back to your server when you're done, or even you could call back to your server right away, or you can transfer calls. It depends on what your use case is, but the point is, it's a very good integration point for getting started on SignalWire if you already have an infrastructure. Well, advanced LAML, simple IVR. Okay, so this, I'm going to skip this for the sake of looking at, so this is going to be tomorrow. Integrations, Agora. I said we have integrations with Agora, Google Dialogflow, and Zapier, etc. Okay, so this was the first part, which we did a little bit quicker than, because that's where I wanted to get. So everybody now has a SignalWire account. We went through a few general knowledge things, such as what a space is, which is your account, what a project is, logical grouping, and few caveats about how to send messages. We are able to register SIP devices. We're able to receive calls. But now we want to do something very interesting. So this is not the first time we look at Relay, but it is the first time I use this for a presentation at ClueCon. So it's the first time in a sense. So what is Relay? First of all, I'll pause here for a bit. There's a link to the slides at the bottom. So that's TGI2021 SW, which is not very readable. Not to read it, but whatever. I'll put it in the chat. Sorry for not picking a better abbreviation. TGI2021 SW. So if someone would like to just follow along, this will be a very good starting point. But other than that, we'll be actually doing some stuff hands-on. So it's going to be more interesting. Okay, so first of all, what is Relay? Who knows? Well, I do. Okay, so Relay is a call control protocol that is based around a persistent connection and has a over WebSockets. So it uses JSON payloads and has a low latency mode. We strive to be below 50 milliseconds at any given time, and it's self-load balancing and reconnecting, and it has the ability to actually distribute load between all of the clients you have running at the same time. Okay, good. How does it look like? Okay, so keep in mind, we have SDKs for all of this, so you generally don't want to be reading the JSON, but sometimes you have to. It is just JSON. So as you can see, there's what you're seeing here is a request to begin a call. So node ID and protocol are just internal stuff. Method calling begin. Params will be tag. This is just custom client data. Region US. So you're requesting a call to be placed from a specific region. We currently only support US, but we're rolling out pretty quickly. It's a phone call, and it's from this number. Again, the caller ID has to be has to abide the same rules that we went through earlier. That's universal. And the 2 number is the destination, and the timeout is how long the call will ring before it gets hung up. Relay also supports a total duration limit. So you can set a call to only last, I don't know, 2 hours at maximum, so you don't incur into weird charges. Okay, so installing the SDK is I'm a Rubyist by trade, I will say. So I generally use Ruby, but really anything will work here. The we have SDKs for Ruby, Python, PHP, C#, and Node.js. So you can use anything you like. I'll be using the JavaScript one for this demo. So let me go grab my window here. I don't know what it is. Okay, so of course, installing the SDK won't do much. Something else we have available is we do have a relay Docker image. We have a relay Docker image list that you can use to get started. So that's really your call. Actually, let's use that. So let me grab a link here. Okay, there we go. So this is where our Docker images live. It's all pretty simple, and we'll be looking at the simplest stuff. So while the examples are available on all languages, we can go through a few of them just to take a look. So all of these are just hello world types of images. So we'll take a look really quickly. Okay, here we go. Oh, I have a commit I forgot to make. I'll get it later. Okay, so what's in here? We have C#, Node, PHP, Python, and Ruby. I'll go look for the Ruby one. I'll make the font a little bit bigger. So you can also follow along just looking at the repository. Sorry, this word was escaping me. So what's in here is just a simple setup. So first of all, just to get the Docker file out of the way, it's interesting how Relay is easy to use. So people are used to complicated setups, etc. So this is the first important difference between Relay and using LAML or other mechanisms. Any Relay consumer runs in a non-privileged way without needing any open ports because the connection is outbound to the servers. And so there's a question in chat. Can you use Relay without the SDK, just using the JSON payload to a REST API? Actually not, because of the event model, etc. It's a bit too dynamic for using webhooks. You'd get a lot of requests. So that's something that we thought about for a while. Then we realized this mechanism is actually, in a sense, better. So again, Relay will connect to the servers using a simple process that will connect outbound. So you don't really need to know anything about it, other than it would just connect and run. So first of all, let me show you what the Docker file looks like. Docker file is 5 lines of code, and it does nothing. That's because the library is actually one single include, and it doesn't have too many dependencies only. So if you look at our gem file, note that I'm doing this in Ruby, but there's only one gem here. It's SignalWire, and it itself doesn't have very many requirements. Okay, so let's get to the important part, which is the consumer. What is a Relay consumer? A Relay consumer is the class you are supposed to subclass to run your own code. So it's providing an interesting set of webhooks that you can not webhooks, of event handlers that you can trigger in your call. For example, you can do something when the consumer is ready, etc. Let's take a look at the Ruby one for the example. So it's not going to be very. Oh, sorry. Super easy. In fact, let's Vim. Readable here. Okay, so as you can see here, the consumer is also very, very, very short. This is an inbound consumer. What does this do from top to bottom? We enable debugging, which is just a standard logger, really. Then we register to a context. What does a context do? A context is just a way for you to tie your incoming calls to the actual consumer. So when you have the IDs on your projects, you can do multiple incoming calls. You can do multiple incoming contexts, and you can split them out between different fleets of consumers. So, for example, this will only take calls for the context that's called Office. This will be more apparent in just a second. I'm just showing you the code first, and then we'll run this. Okay, so the incoming call method is defined by the consumer along some others in the API, and it's similar in all languages, by the way. So there's the exact same mechanism available in all languages. What happens here is that every time the consumer receives a call, it will spin off the equivalent of a thread. Let's not say thread, because people usually get me and say, "Hey, those are not threads. It's Ruby." You're right. Those are not threads. So it will spin off a concurrent process that will handle the call separately. These are very lightweight processes. They just do some signaling. As a result of that, they are very capable of running a lot of traffic. We've seen people run 1,000 concurrent calls on one consumer on JavaScript. So what we do here is the usual dial planish stuff. So we are answering the call, playing some TTS, and then hanging up. We're just saying welcome to SignalWire, and then we'll just run the consumer. So from a pure running standpoint, this is pretty simple actually. So instead of running in Docker, I'll be running directly here, or not. Maybe do we have an environment set up here? No. Mm-hmm. So I will change these keys later. Okay, so I'm running the consumer, just using the README stuff. It's there we go. We're receiving all inbound requested to relay context and available scopes. So let's exit full screen for a second, because I like to do things in parallel, and I'll put this here, and I'll go grab a Chrome window. Put that there. Okay, so now I'll go into my space. Change the project I was using, which is grab one of my numbers here. Should be this one. I hope the token is actually correct. And then so here's how you set it up. It's very simple, and it's apparent. So I have a phone number in my dashboard. I will go set it up as a relay endpoint, and then I will specify Office here as the destination. But this is a little bit bigger. Okay, so check out as this is set up. So I'm setting it up for voice calls, handling calls using relay. When a call comes in, forward the call to this relay context, Office. So relay contexts are really just a way to separate calls between different consumers or groups of consumers, and in general to separate tasks, etc. So I'll just save this. Then I'll grab my trusty Bria and copy the number and place a call, and hopefully this is the correct token. I don't know why this is so gray here. Oh, so something with how I moved the screen. Okay, so let's go. Okay, so this was just a simple call, but it's a good thing to get started. You know what? Let's do some quick thing here. I'll set my preferences to not having the transparent background. numbers. Much better, right? Okay, good. Phil, this is going to help. Great. So let's go back to what happened here. Again, I'm showing this mostly to, it's for our own learning, because really there's no need to go look at the actual parameters. So remember, we stop at this line, which is receiving all inbound related to request the relay context and available scopes. So you notice the similarities there are to any control protocol such as ESL. These are all pings. Pings are keeping the WebSocket alive. This is an unfortunately necessity. You can turn off the debugging, of course, but this is generally necessary because WebSocket servers tend to go down after a while, and many firewalls don't play nice with persistent WebSocket connections unless you keep them alive in a while. But here we go. So we're getting a call receive event here. And it's from this number, and that's my number, and it's going to a state of ringing, and we're answering the call, and then we're getting a call state of answered. You notice there's a lot of similarities with what you can do on ESL, really. And then we're playing TTS, welcome to SignalWire. Then we're hanging up. So effectively, this is a very interesting and effective way of building call control. Well, you also get sub-states such as playing, finished playing, etc. So you're able to actually react to any sub-event that you're seeing in the console. It's a great way to build interactive applications that are really, really effective and useful. What else? Well, this was our first demo, of course. We'll look at a few other interesting examples in a bit. But for now, let's go back to some of the definitions of relay so we can keep going. As you see, it's pretty simple. Again, the most important thing about relay, well, aside from all the rest of the things, is that really it can be run without any privilege. You literally only have to be able to run a process in your favorite language and it will work. There's no ports to contend to, there's no permissions to contend to, it will just work. This is generally very important when you're adding telephony or when you're adding existing functionality to an already existing application, such as your FreeSwitch fleet. You could just stand up a separate relay process doing all the cool things relay does, and we'll see more, and go from there. So let's do a quick dive into relay concepts before we go look to a couple real-life applications. What a consumer is, again, we just saw it, is the class you're supposed to use to subclass to run your own code. There's the equivalent in all of the various languages, and there's examples in all the various languages. And you usually either register on a call, on an incoming call, but you can also use tasks to trigger outbound calls, which is something we'll take a look. For now, you can see how easy it is to just answer a call, play TTS, and then hang up. Now you'll say, well, Luca, if I had to travel all this way, so nowhere because we went nowhere, but if I had to virtually travel all this way to just find out you can only play TTS, well, that's interesting. Good, thank you. Well, relay can do a lot of other stuff. Aside from the usual suspects of playing audio, etc., it's able to do many asynchronous things which are not possible with LAML and are even difficult to do in FreeSwitch only sometimes. So you can play audio. You can do anything really. All of the methods that you're seeing can be used either synchronously or asynchronously. So you can do some very, very cool stuff, such as you can play audio while your application is working, without having to figure out a way to thread it out, without having to figure out a way to make your application do something while web request is going. None of that. You can just start playing the audio, loop it if you need. It's not shown there, but there's a loop. There's a loop parameter, and then you can just do whatever you need, and then you stop the playing when you're done. So effectively, this allows you to build the classic situation where you're playing some audio while your database, your attendant is searching for something. More and more over the last couple of years, I would say, they were available before, but let's be honest, it's been a couple of years since they've been very good. Many people have been using chatbots and automated attendants to run their own calls. And sometimes they have to look up stuff in databases. Think, I don't know, a travel bot that's helping you find a flight. It can usually take quite a while. And sometimes those APIs are slow and it's not your fault. So you can at least play some waiting music. It's not great, but the alternative will be just waiting in front of dead air and probably hanging up. And this is just one of the simplest ideas. For example, you could be detecting DTMF during the call to implement some kind of assistant or call transfer or whatever. There's plenty of things we can do, and we'll see a couple. SignalWire is able to play text-to-speech, silence, which is also useful, or audio. Silence is actually silence playing for the media telephony people amongst us. Is not lack of RTP. It's actually playing a silent RTP. So it's keeping the flow up, so it won't time out your stuff. And audio just plays URLs. You can give it from anywhere. It supports MP3 and WAV and most normal encodings. You can dial another call. So, of course, your relay handler can dial another call, and you can do call connect. So the parameters there are maybe a little bit hard to read because of the syntax, but we'll simplify that since then. But the point is, you can dial a call and wait for it to end. So dial a call means this is an incoming call answer, reading through the code. So you get a call, you answer, you're calling another number, you're bridging them. If the other number answers, we just wait for the call to end. Oh, wow, a double click doesn't work. Or if the other number doesn't pick up, we just hang up. Here we could be playing where we have a comment failed to connect. We could be playing something like, sorry, we could not reach your destination, or whatever. Receiving input. Relay has a very featureful set of input features. So you can do text-to-speech, you can do digits, you can do prompts, you can do a lot of things together. It's LAML, and it's a bit more configurable. In fact, there's more variables exposed in the API, but it's similar. You can do text, you can do speech, you can do digits, or you can do both. Speech recognition, you can also do open-ended speech recognition. Just prompt for text, and it will return on the auto timeout. So do a quick transcription of sorts. This is what you'd use to plug in a chatbot, a text chatbot of sorts. I use this with Rasa NLU, an application we're building to actually do a voice chatbot. So using text-to-speech without any other, using ASR without any other parameters, returns very quickly and is very well suited to high interaction stuff. So I use this for chatbots. So when you have a result, you can just use the result to feed it to the chatbot and then do whatever the chatbot says. It's actually a pretty easy loop once you have it going. It's harder to build a chatbot than to build a telephony for sure. What else? You can do recording, usual suspects, have a beep, not have a beep. At the end, it will return a URL for the recording. So you can use that for your own things. The URL would be an S3, well, it would be actually a SignalWire storage URL that's a public unguessable URI, which for the people that are interested about that is HIPAA compliant because it's a unique unguessable URL. So even if it's public, there's no problem there. You can always remove recordings and calls from our records using the API. So if you need true record purging, you can just remove them as soon as you move the recording elsewhere. TAP is very interesting. What does TAP do? TAP allows you to take one or both of the lags of a call and send the media as it is flowing to a different RTP or WebSocket destination. Effectively, you just send the raw RTP to, well, in this case, localhost 8088, which might not be super useful, but it is a very, it depends on what's waiting there. We have customers using this to do advanced transcription. So you get the raw RTP, they have their own engines they're running locally, and they just send the RTP to their own engines and then interact with the call using the async stuff. Of course, TAP media here is invoked with an exclamation mark, which in Ruby means it's an asynchronous method. Why is it so? Because otherwise the call would just block here. So you always have the liberty of either blocking or non-blocking when an action is happening, which is one of the key features of Relay, really. The ability to do anything asynchronously. So you might be interested in, okay, Luca, you showed us a lot of examples about inbound calls. What about outbound calling? Outbound calling is a task. So how do we interact with relay consumer? A relay consumer is its own process, so it presents the same challenges as running any other process. How would I talk to it? In Ruby, I could use DRB. I could use some kind of processing queue. So since it's just a process, it could be running its own polling mechanism for Redis or AMQP or RabbitMQ or whatever. But why don't you use relay tasks instead? So instead of having you set up your infrastructure, we set one up for you. A relay task is a message your application can send to SignalWire. SignalWire will then distribute those messages to the first available consumer, load balancing the work for you. So if you have 10 consumers running and you send a task to SignalWire, only one of the consumers will receive the task and handle it. This is, so first of all, you will want to register for tasks. It's done the same way as using the context. So you have to have a context defined. In this case, it's incoming. And then when you get a call, when you get a task, you can do something. What you're seeing on screen calls the to-number field of the task message from this number. So effectively places a call and then says hello from SignalWire. I have an application to show you that's very interesting here. And we can take a look. I mean, just let's go through the sending the task very briefly. So sending a task is what you do in your application. So what you're seeing on screen here is not part of relay. It's just Ruby or JavaScript or whatever. A relay task is just an API call. When you call deliver, the task will be taken, sent to SignalWire, sent to the proper context, and distributed to one of the consumers without you having to do anything. Which effectively means if you're implementing a high volume outbound dialer, for example, all you need to do is stand up half a dozen of consumers and just start firing tasks out to them. And SignalWire will distribute them correctly, route the calls, queue the calls as necessary, and everything will just work. TM. So that is that's, in my opinion, is a very good improvement. And honestly, Task has been very valuable for people building very high throughput dollars, to the point where I've seen dollars that are quite much faster than anything you can run locally on FreeSwitch, just because of the scale we have available. So let's take a look at this, and then we'll go to look at the finished application and maybe even run it, because it's very interesting. Answering machine detection is something that we've been working on for a long while. Actually, Relay has the ability to not only detect machine detection, but also detect machines, of course, but also faxes and digits. But let's focus on AMD. AMD has a lot of different parameters you can work on. There's word count, timeout, initial timeout, interword timeout, etc. So you can tune it for your own usage, and you can also wait for the beep. So it will actually play the correct if you want to leave a message to a machine, you can just do that. Compared to the LAML AMD, this is much better for two reasons. One, the technology is actually different, and it's a mixture of various secret sauces we have inside SignalWire. And two, there's more parameters you can change. So if your application relies on very precise and as quick as possible AMD, and I'm saying as quick as possible because generally speaking, as you know, the AMD does require a few seconds in any case. You can be quick, but you cannot be too fast or just always get unknown. So this is going to be as quick as it goes. It's very, very effective. Usually, you can usually keep the interaction below 4 seconds probably, which is quite good for AMD. Because as you know, as AMD works, it will literally just listen to what people are saying on the other side. So before you can tell someone is an answer machine, it does take, at least they have to utter 4 or 5 words. By the time has passed, so you know they are an answer machine or not. You can even detect faxes. So if you're calling numbers and you're not sure if they're faxes or not, because, you know, people still do faxing. I don't know why, but whatever. If you really, really, really want to do faxing, you can. It will work. You can even detect the fax, so you don't waste minutes sending the fax to a number that is not a fax. That is actually a very important. Thing about Relay. If you're doing a lot of outbound faxes to numbers that you don't know if you are faxes or not, which is a use case we have people doing, A relay enables you to detect if a call number is actually a fax. We support all the various US and international tones, so you can set up exactly which detector you want. But it's very important to know that you can actually detect faxes and fax machines and only send the document to those machines. That will save you quite a bit of minutes compared to just blindly sending out. So let's stop here instead of going into messaging, and let's go take a look at the application, which is very interesting. I'll also put a link in the your chat if I can find the. Okay, so this is actually a preview. Tomorrow we'll be doing some content that's a bit less technical about the about Relay, and one of the things we'll be looking at is this very application, which I'll show you as a preview here. So there's plenty of other examples, but this one is particularly fitting because it goes over almost everything that we touched on before. So what this application actually does, and I'll put the link in chat. I'm going to close this because we don't need it anymore. Link in the chat here. What this application actually does, this application is a simple auto dialer app that will place calls out to Relay. So let's go look at the meat of the application. You remember we went through consumers and we discussed how a consumer is your building block for anything on Relay. This application just runs on a single consumer, really. So it's pretty simple to run. And it's not very long. It's if you don't count the boilerplate, it's less than 30 lines long. So what happens here is that we register to. Okay. Sorry, the screen was slow to update. Okay, so let's go through what we're looking at here. This is just a task consumer. So keep in mind, you can have consumers that do both. Nothing is stopping you from defining an inbound call and from an on-task handler. And then consumers will react differently if they're receiving a call, if they're receiving a task, if they're receiving a message. You can have one consumer do everything. You don't need multiple ones. But of course, this is an outbound dialer. So what we have here is that we have a web application that just runs, and then I'll Docker up this actually. Cool. Okay. While this Docker is up, I'll take a look. So what happens here is that we receive a task message. Then I just pulled the destination from the task because it's easier to read. And then I will run the call. So I will create a new call from the number I've set up to a destination here. Let me zoom in a little bit more if Chrome allows me to. Perfect. Okay, good. Then we'll get the result. This send event method you're seeing go on from time to time is just a quick HTTP post that goes to the web app, which we'll look at very briefly. Really, what the web app does is just this. So this is just connected to Fay. So it's a WebSocket engine. And again, this is a preview. You can join us tomorrow too, but let's delve into it. So ignore the send event is just messages. So if the dial result is successful, it means we have reached the destination. Then what we do is we want to detect your machine. We'll go for a threshold of 8 words and wait for beep of true. So that way we can leave a message. If the MD result is human, as you can see, we'll just send them to the agent. Sending them to the agent consists of bridging them using connect to a target number and then waiting for the call to end effectively. They're just talking. If it's not human, we'll leave a message and we'll say, hello, we tried to reach you and blah, blah. Wait for beep will automatically place the message after the beep. So you always leave the message in the right place. Regarding the, yes, David? Okay, well, just wrap it up. So send events about the call being ended, etc. This is very, very simple. I'll pull the actual terminal in here. So I have it running in Docker at the... Where did that go now? So I'll close this. Note that I'm running multiple consumers at this point here. One is not on Docker. The beauty of Relay is how easy it is to just run it, and it will just connect and work. Relay just works, which sounds like a weird call out, but it's really all there is to it. No, you can't actually do that. Oh, okay. Yeah. Okay. You can't do that, but yeah, it was answered. Thank you, Giovanni.
It's the Italians looking after each other on the.
Oh yeah. It's the Italian voice over IP mafia we used to be called. And that's not like a great name, but still, it's Italian. So okay, so let's see what happens here. The consumer is running here, and just a quick look at the web app first before we run the actual application here. So the app is just a web. Here's the meat. This is what I wanted to show you. So this perform mechanism just sends a task using task deliver to the dialer. Every time this is hit, it will just send a message to SignalWire and back to my consumer in here. It's running locally. And I will, of course, there's a few other things here, but here's it. Post start. For each number, I will perform that task that does the tasking thing. So that just run it. So I remove my our director of product numbers here because I don't want to call him right now, but let's see what happens. So see the relay running, and you can see. So 94 here, this number here is an answer machine. 94. While the 77 number is actually a number I set up to fail on purpose. It's rejecting the call. So we'll have the message. We have a call in here, and now we can go see where it is in the dashboard. So even if you don't have a full API application built, you can always go to the dashboard in SignalWire and see where your stuff is. Usage, and there we go. This is the call I just placed, and this is the recording, which you can down. So as you can see, the relay syntax itself is very powerful. It's actually super useful and does a lot of interesting stuff. Of course, it supports messaging. So there's links to all of this at the end, but I can add more. The messaging is actually, you can do messaging or relay. It will work very well. Messaging is the one place where REST might be better suited, because messaging consists of either one, so if you're using relay to connect the first leg PSTN call to SIP call. So SIP bridging capabilities are coming soon. They're not in quite yet, but you will be able to modify call rate at that point, because you are calling out to SIP. So anytime you're calling out to SIP to SignalWire, not only restricted to relay or LAML, anywhere, you're able to put in your own call ID, and then it's up to the SIP destination to decide if they're accepted or not, much like any of your carriers do. So if you send a caller ID that's not right, they will probably not accept the call, but some of them will. Like, it really depends on how your trunks are set up. So anytime you bridge to a SIP call, yes, you're able to set your caller ID as you want. Again, messaging, as I said, is REST request on sending out and webhooks on receiving. But if you're already using relay for something else and you want to do an incoming message handler, you could have that running too. Otherwise, I will probably suggest using HTTP. I generally prefer that. Okay, so we're just in the nick of time, and there's the presentation has a link here to sign up for tomorrow's dollar thing. You already saw the dollar, but we'll go more in depth tomorrow and run a few more things on there. So it's probably worth joining still if you'd like to. I didn't press enter here. Okay, cool.
That's very smooth, Luca. You've brought it right in for a landing, bang on the 2 o'clock. How did you manage that?
Oh, a lot of rehearsals. Everybody knows that's not true, right? So I'm
excellent stuff.
Nobody believes you if you say that. So I've just done this a few times. So again, Relay is sort of a spiritual successor to ESL. Any questions you have, any ideas you have, anything you try to build, reach out to myself or the team. We'd be happy to help you. And thank you for being here.
Thank you, Luca. Thank you very much. Really appreciate that. Have you got time to hang around in case there's any further questions?
Of course, I'm here.
Good news. Okay. All right. Well, that's the formal kind of end of the session.